G'day, I'm Neil and my handle is Wiley11. I'm just going to put my disclaimer here. Whatever I do and say on these videos is well-intentioned and well-meaning advice. I accept no liabilities whatsoever for any disclosures. If you take some advice or act on something that I'm saying on these videos, you do so entirely at your own risk. I'm doing it based on my experience. These videos are my attempt to give back to YouTube for the help and assistance that YouTube has given me. So once again, you follow along or follow advice from these videos entirely at your own risk. Okay, and if you're not happy to do that, click this off and off you go. Because this is purely my attempt to give back to YouTube, as I said, for the help and advice that I have received out of YouTube. So this is just my little attempt to give back. If you're happy to follow along at your own risk, buckle up, sit in. Let's get into it. Hi, and welcome back to part 2 of our epilogue in the 3D printer build, which is actually using your 3D printer. Oh, I've just got distracted here for a sec. Just give me a second. Oh, okay, that's fine. Okay, so I've got a few things going on. I'm going to try to get this introduction through while these things are going. I'm going to get distracted, I can tell you. I've got a thing happening here, but I've just got to keep an eye on. What we're going to do is we're going to make this little box, little project box that I built for this little board. Alright, this is a standard size of these boards, you buy them. This is just perf board, it's nothing special. You can buy these in packets like I bought mine. I think I bought a packet of 50 or something. And what they do is they hold your little testing projects or your little prototyping projects. This is a testing one. This takes a programmer. But as you can see, the box just holds my little perfboard PCB and stops all this stuff from shorting out on your desktop. Pretty handy little thing. That's the permanent home for that one. It's made specifically for that. I cut this out, but I could have actually incorporated that into the design had I thought about it a little bit more than I did. As it stands, this little board has done its job. I'm now finished with it, and I need to make a couple more for different reasons. So it's actually led me in a new direction of research, and I've got to build a couple more boxes. So I thought I'd do that and share that with you guys. Hey, I'm still distracted. Isn't that interesting? Alright. That needs to happen, doesn't it? I'm going to have to, at some point, cut this off and get back onto this. What we're going to do is we're going to open up a copy of OpenSCAD. I've actually want to rebuild the file for that little perforation box step by step with you. And I want to explain what it is I'm doing as I go. Now, what I'm going to teach you is a thing called object-oriented design. Okay, it's not in the strictest forms object-oriented programming. All right, so let's get that out there. It's not that. So what you've got to start off with is some kind of idea of what you're trying to design. Now, what I did was I drew mine out on a piece of paper, and I'm going to do that right now. Again, a second time. I want you to see that nothing happens without some direction. The best way for people to get direction, I think, is to sketch it out. See, everything I do has sketches in it. It may not look like much, but these are all plans for things. You know, this is another plan that I did for something else, right? So you always want to start with some idea of what you want. And I always find it helps, even if it's a stick figure, a stick chart, whatever it is. I always find that it helps to kind of sketch it out. you know, even with I've only got like an old pen here that someone gave me from Australia Post. And what I want to do is I want to sketch out what this thing's going to be. So I'm just going to really quickly design this thing. It's going to have, and now I know you can't see what I'm doing, but you can see I'm just going to sketch it out. I'm not the world's greatest drawer. Let's put that out there. This thing's just going to be like this. It's got to have a bit there for the programmer to come in. It's got to have a thing in the corner. It's got to have a thing to support the PCBs. So they got to be in there. And again, I'm not the best drawer in the world, but you'll get the idea when you see what I've come up with. So there it is. And that'll go there, down, you know. So that's basically what we're going to be building. There it is. Now I'm just going to quickly talk to you about what this is. This is a box. It's got height. It's got to have a thickness. So these walls have got to have some kind of thickness to them. These are standoffs, right, for the PCB. So they're going to have to be sitting into the bottom of the corners. They're little triangular prisms. And that's it. So what we've got, this box I'm going to call my chassis. So now I'm going to label my bits. I'm going to call my box my chassis. So if this was a vehicle, this would be the chassis of a vehicle, right? That's my chassis. And these things in here I'm going to call PCB mounts. Oops, I did that upside down. Got to do it the way I'm. Righto. So we've got a chassis and we've got PCB mounts, and this thing here will be the cutout. I'm also going to put one other thing in the box which I find would be useful. I'm going to put a relief notch in it so you can stick a screwdriver in under your board and flick it up out of there. Because when you're building the board, sometimes you've got to make changes to it, and it's not always good to stick something in underneath this, which is a little bit fragile, and it's, you know, it really needs more support. Actually, that's something to think about, whether you build a little thing underneath it to give it some more support, because it's where the plug goes, right? And it can get quite fragile, so you might think about what you need in there. So cut out programmer. Support. So that could be a program plug support. I'm going to think about that and think about whether to include that or to do that as a modification to the design at some point down the road. That's our box. And I'm going to call this our project box. So now what I'll do is I'll start a folder called Project Box Design, and I'll put that in it, right? And that we'll keep that. Now the first thing we need is some measurements, and what we're going to do is we're going to measure off something that we've already got. Now I already know what these measurements are, obviously, but I pick up one of my boards and I want it to fit these boards. So I already know my length. My length goes this way, that's my Y, and that's my X. So that's my X and Y inner dimension. So we've got the X and Y inner dimensions, right? Then I want to decide how thick this is, and what I've done is I've made this 2 mil thick. So I'm just going to make some notes on a bit of paper over here. I've got my X dimension, you know, Y equals, right? And I'm gonna call Z I think I called that 10 millimeters. Righto, so from this scratch we've now got ourselves a plan, right? So we've got our inner dimensions X, Y, Z. I know these values, I'll get them from the software and fill these in later on, but this is our plan, this is what we're working to. And what we're going to do is we're going to build this as a module, we're going to build the chassis as a module, which is basically our box. We're going to build our cutout as a module, and we're going to build our relief as a module. Okay? So this and this will basically be the same thing, only they're going to have different dimensions. Right? It's going to be a much bigger cutout than this is. Righto, so let's get into it. Let's start working with it. Now I'm going to swap cameras. I'm just going to put a plug in for nightglowmanufacturing.com. Don't forget to support our company and buy our merchandise so that we can keep moving forwards with all of our plans. If you're coming in here, this is part 2. You really should go back and look at part 1. And what we're going to do now is we're going to swap to the other camera and we're going to do our screen capture. I don't know how we work this out, but we're going to work something out. But what we want to do is we want to do a full-on screen capture of what we're doing, so that you'll see, you know, how to pull together the sketch from just these basic things. Now, remember I talked about object-oriented design. This is not programming. Object-oriented programming is related to it, but you've got to design something. And the design is in identifying the objects. And that's exactly what we did in that sketch. We had a chassis, we had some supports, and we had some cutouts. So we actually have four objects. We have a chassis, we have supports, we have a relief, and we have the program plugs cutout. I'll decide whether I add a 5th object later. If I need to, I can come in, insert the object, and insert it into the design. And this is the beautiful thing about object. You don't throw the whole thing out because you came in somewhere. If your design's all over the place, you don't know where to put it. If your design is structured, you know exactly where to put it. And this is a good practice to get into. If you're starting out, think about things as what bits make it up. That's all it is. What bits go into making it up. And you've got to list them all out. Bang, 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 bang. You make yourself a list of all the bits. And we can do that here. Right? We did that. Our list is a little bit convoluted, but we got a list. Now all we've got to do is collect all this. Right? We collected this here. We've got X, Y, and Z. We've also got a thing called thickness, which we've called thick. And I'm going to call that 2 millimeters. X and Y we don't know. So there are our dimensions. We know the thickness of our PCB, right? It's 2 mil. So it's the same as thick.
Okay, so what you're looking at here is give myself a little bit of a lip there via a USB
so
cable
I actually just go
to
thick
my
plus
3D printer. So it's a Windows
plus
system.
No, why don't we just do PCB offset?
3D printer.
Alright, so let's just call it a value, and that way we can change the height of the PCB in the box. So let's call it the PCB offset from the top. Let's make it 3 millimeters. Right, so we've collected some variables. Here they are. Here's our variables. We've collected some objects. Here they are. We've got those. Now we're ready to start thinking about how do we bring this together as a project. How do we do that? Well, the answer is we follow our plan. Well, let's get into that. Now I'm going to swap cameras on you. I'm going to pull up the screen capture one. That process is pretty convoluted, so it actually drops out on me after 5 seconds at a time because I'm using Ice Cream Screen Recorder to do it. Now, it's a pretty good product. It's actually very versatile, but I haven't bought it, so every 5 seconds the thing's going to cut out, and I need to remember where we're up to because it doesn't beep me, it just goes away, and then I might lose a bit of stuff. So let's keep going, and as soon as I get enough money together, I'll go out and buy Mr. Ice Cream Screen Recorder's software, and we'll be good. Righto. Okay, so just in the break there, it's been a while, it's actually another day's gone by. I grabbed my calipers, measured the board so I got the right dimensions for our box, and the magic numbers are X equals 51 and Y equals 71. So we've now got our X and our Y and Z dimensions. We didn't go to 10 in the original, we actually went to 7, so I'm going to change that 10 to a 7. We used a 3mm cell wall, and our PCB offset is actually the same as our thickness. So the depth of this here to here is 3mm, and the wall thickness is also 3mm. Now I haven't decided about this, and I haven't decided about this yet, except that the depth needs to be whatever the PCB depth is, plus, you know, 0.5 millimeter, so you can get a screwdriver blade under it and pry it up. So this relief here, this will be 4. millimeters, right, which equals PCB depth plus 1 millimeter, right? So we're getting together some values for our properties of these objects, right? That's what we're doing. And as we're going, we're modifying our drawing. So we've got our X, Y, and Z. We've got our thickness of our wall. We've got our PCB offset. So this is the offset. I've just done this roughly. So our offset now has an arrow to this that represents that gap. We haven't got these dimensions yet, which we can get fairly quickly because we've got them right here. Right? I actually did this with a knife. Doesn't need to be that big. Oh yes, it does. It needs to be the width of the programmer, because the programmer comes inside that. Right? So it's the width of our programmer. So let's get that measurement. It's exactly 40 mil. So that's 40 mil. We could get away with 35 because it's got bevels. Okay? With these beveled edges, these rounded edges, that's 35, and that gets us in deep enough. So let's make it 35, our gap. That'll do me. Alright. So it's going to equals 35. It's in the wrong place. 35 millimeters wide. Okay, so what I'm doing is I'm adding more properties. This is our cutout. This should be 35 millimeters wide, so that the end of that can go into it. So that'll go in. Look at that, almost drew it to scale. How's that? How good's that? Almost drawn to scale. How's that for a coincidence?
shear flute, but it'll go in enough that it'll connect with the what's that thing called? It's called a header, right? That's what it's called. Alright, so what else? What else? I really don't know what else to do other than to get into it. I've got a whole bunch of measurements. I'm going to swap over to the onboard camera. I've changed my shirt. As you can see, it's still really hot here. It's humid. The Australian bushfires have not gone anywhere. They've really made our weather stupid. And even though there's a breeze out there, it's blowing in the wrong direction for this unit to capture it. So I'm getting a little bit of a breeze every so often. But once you get out of the breeze, it's hot and muggy. And you wouldn't believe just how hot it is. So, we're just going to keep pressing forward. OpenSCAD open. And I always start out my projects. Just don't read into all this stuff for the moment. I just want to talk to you about how to lay out your project. I always start out with, you know, what version and what the project is. So this is version 1 of our project box. I always use who's done it. If one of my employees has done it, that their name would be in there. Why is it whenever I start to record, some idiot goes up the street? Anyway, or either that or the whippersnipper guy starts up. Anyway, designed by me, and the date I designed it. Actually did this on the 21st of August in 2019. So I actually made this sketch some time ago. I'm actually decided to release this, so I'm going to put a disclaimer in here, and that's it. Okay, but a project box doesn't require any further explanation. It is what it is. It's a box. And so now what I'm going to do is I'm going to build this with you on the screen. Here's one I prepared earlier. Where we actually build it is right here in this section. This is it. So what we do is we create the chassis, which is this outer box. Actually, let's show you. I'm going to comment out the pieces. Now the two slashes like that are comments. So I've just commented out everything other than the chassis. Alright, so the chassis is over here. Here it is. And what this is a box. There's nothing special about this. It's a hollowed out box. It's essentially one cube inside of another cube. That's all it is. In our instance, what we've done is we've built this chassis. And here it is. The chassis is the frame about which all of the objects are built. And in this application, it's a hollow box. So if I had a more complicated shape, it would go in here. Or it would be built here as a result of whatever properties and methods, properties and methods go into making it up. Now here you can see I'm using some variables. Here's my cube, my first one, outer box, and I'm saying I want a cube. Now at this point I'm going to show you something. If you're connected to the internet, you have a fairly substantial help available to you. You need to be connected to the internet, and here's a thing called cheat sheet. Now this cheat sheet is your best friend. So when we go in here, you can see it's going to OpenSCAD's cheat sheet index, and this hasn't been updated since May, right? Or for this particular version. Now, here's our cube. It's a 3D object. And here is the syntax for the script. Cube, size, center, blah, blah, blah. And down here somewhere, there it is. It's got also a thing called box, which can do the same thing. But here's your cube. So if you want to center your design, it means about putting it equilaterally around the origin, which I like my chassis to be centered. I always like it to be sort of in the middle. That's not always the case, you know, you don't always need to do that. So you can do a basic cube like that, or you can do false. This one here isn't centered around the origin, it's actually butted up hard into the origin, XYZ. So this is your best friend. This little cheat sheet, you can go back and you can see you've got 2Ds, you've got 3Ds, you've got union, difference and intersection. These are very, very useful things to come to understand. So our chassis is actually a difference, and we're going to talk about this difference, because what we've done is we've used one shape to cut out two spheres or cylinders, sorry. So what they've done is they've done this difference. Here's the script, and they've put in a cylinder, which is this vertical cylinder, and then they've put in a rotate. They've rotated a cylinder 90 degrees. Here it is, rotated 90 degrees in the X-plane, and they've put in a second cylinder. So what they've done is they've used that second cylinder to cut a hole in the first. How cool is that? And you can see you can cut it at angles. You can do all sorts of wonderful things with cylinder with difference. So you think of union as combining solid materials. Here's union. It's the opposite of difference. So what it does is the same thing with union. So here's that second cylinder at 90 degrees. So by combining the material, you use union to combine it, and you use different to cut it. Difference. That's the distinction between union, and they're the most commonly used things in OpenSCAD, right? So let's just minimize that for a sec and come back here. So here we're using difference. What we're doing is we're putting one cube inside the other. Now what I'm going to do is use the highlighter. The highlighter is this little hash sign. So you can see what's going on. There's the second cube. And you can see I'm using it to cut a piece out of the first cube based on the thickness that I wanted it. Can you see that? Now I'll talk a little bit about this little variable here, this FA. Let's talk about that. What you want is you want to make absolutely certain when you're cutting something that it penetrates. If I took this FA out and rebuilt that, in this instance my cube is actually perfect. Let's just take thickness out. I want to show you what happens if you don't penetrate with your cut. It should be Z. I think it's going to be minus thick. Yeah, that's what happens. See that? You get this random, the software really doesn't know what to do with it. But if I put in the plus FA, which is fine adjustment, I've actually declared it, and now I do it, that randomness is gone. I've actually got my penetration. So what I've done is I've just put this 0.3 of a millimeter fine adjustment to make sure that the design knows I want that to penetrate. And it's going out into open space, so it really doesn't matter that I cut out. You know, if I had some objects up above here, I might need to assess that, you know, where I'm actually cutting. But in this instance, the order in which you do things also matters. Okay, that's the next thing I want to tell you. But now what I'm going to do is I'm actually just going to build this up in sections and go through and explain it. So what we're going to do is we're going to delete all this. And we're going to talk about what we need as we go. Yeah, let's delete it and let's build it from scratch. I'll just leave those dimensions there. Now, don't worry, I did a backup of everything. It's over here. And what I'm going to do is I'm going to bring back in our chassis. Now, there's nothing worse than watching people type, so I'm not going to type all this out. I'm going to spare you that. I'm not bad, but you know, it's boring. So here's our chassis. Now we also need our build. So let's bring the build back as well. Now at the moment this script doesn't know what this method here is. These are methods, right? When you see this, it's calling these modules, and each of these modules does is it actually builds up the object. That's what it does. So here I'm building the project box. Now this is actual script. It's not encapsulated within a method. I could have actually encased this in a method. In fact, I could have said module build project. Right? So this is C. This is C syntax. Right? And up here, I could have just called this single method called build project, which is not a bad way to do things. Because in build project, everything is actually built. So within this, I'm actually changing the aspect of everything, and then I'm doing all of this. Cool. Okay. Maybe that doesn't belong in there. Just for the moment, I'm going to take it out of there and put it back up here. Okay, so what we're working on is this chassis, and we don't know at the moment about this supports, and we don't know about cutouts because we haven't declared anything. All we've done is declare this chassis. And what we should find is that I've given this enough information. So here's the chassis dimensions, which are required to make it all work, and we can run it, and here it is. There's our chassis, all built. Now please remember, I am releasing this code. Okay, so don't madly think that you need to copy all this down. But if you're following along using this code, then you know you'll be able to change. You'll understand what all this means. Now let's just change a few of these numbers just to show you that they do change. So let's make it 61 millimeters wide and rebuild it. Look at that, it got wider. Let's change it to 101. Run it. There you go. Got longer. Let's change the Z. Let's change it to, I don't know, 20. There you go. I've got a really deep project box. Look at that. It's just a box. But by changing these variables, we can now change the attributes of our project. And we can build bigger and bigger boxes. As we get bigger, I'm using control with my mouse wheel to zoom it in and out. And you can see it gives you a convenient measurement. Right? I'm going to put these numbers back to where we need them. So we need X to be 51. I'm reading this straight off our drawing. Our Y is 71. Our Z we said was 7 or 6. What did we say? 7. 7 mil high. Run it. There's our box. We can zoom in using our wheel. Actually, you don't need the control. You just need your wheel. So I'm using the wheel on my mouse. The older versions you did need the control, I think, but I'm a bit old school sometimes. Yeah, you didn't need the control key. So by zooming in and out with the wheel, that's what I'm doing. And when I hold down my mouse, I can move the mouse, and that's how I'm rotating the drawing or in the plane. So there's the X, Y, and Z. Basically, that's how our box looks. Okay, so let's talk about that. We've got our X, which is our width, our adjustment. Now, FA you can use these variables. They don't just need to be used in chassis. They can be used all over the place. Once you declare a variable, it's declared. The trick is you got to declare all your variables early, right? So before you do any method calls, put all your variables. First. And group them by your objects. So as you go through your drawing, we had the chassis. I showed you the, hang on, see if I can show it to you. So we had the chassis, we had our X, Y, and Z, our thick, and the only thing missing from there is our ZA, which we've just nominated. So hopefully that came up. So there it is, X, Y, Z, thick, and our fine adjustment of 0.3 of a millimetre. Just to make sure we get through that layer and that we get our penetration, our cut. Right, so now we're going to put in the PCB supports. So we've got our standoff and our cutout. I'm going to bring all these dimensions in because I don't know what I used where. So I'm just going to bring I've gone through the drawing and I've collected all of the variables I'm going to need, plus a couple that I think I might need. Now I'm going to call your attention to this variable, relief depth. And what I said was I wanted a 1 millimeter, well actually I've called it 1.5 millimeter gap underneath our PCB depth. So you can declare a variable with a relationship to a variable provided you've already declared it. See that? So if you've already declared it, you can use it. But if I declared that down here, so if this, for example, was down there, and I go to build this, I'm going to get a warning. It doesn't know what to do with that. See that? But if I put it back where it belongs, we're still fine. Everything's working. So you've got to make sure that if you've used one of these, that it's already declared somewhere in the script above it. That's the first trick to this. But now because I've used this thick, wherever I build this relief depth, it will be related back to this thickness. And I don't have to think about, oh well, if I'd said this was 4.5, I changed the depth to 3, now I've got to change this to something else. Well, I don't need to think about that. It just happens, right? So compound variables or dependent variables can be built. So dependencies can be built into the project, as can compounds, what I'm trying to say, compound structures. So it's also the same with a structure. So if you build an object, let's say we cut a cylinder with another cylinder, If the first cylinder doesn't exist, let's going back to our example. If this doesn't exist and we did this, so if we just did rotate cylinder blah 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 and then we declared this below it, you'd get a different result. What would happen is this cylinder would cut through this one and you'd get two pieces of cylinder on either side. So the order in which you do things matters. That's what I'm trying to make and let's just show you how that works. Oh, let's not. You get what I mean. If I declared this as the second cylinder, this cylinder here would be drawn first, right? And then this cylinder here would cut this cylinder in half, and you'd have two bits of cylinder with a hole, this, you know, separated by this hole. I'm not going to say any more about that. You can play with it. I want to move on with this. So the next thing we want to do is build our PCB supports. Now, these are a little bit complex. Here they are. And you can see I'm using a method to say build them. And here I'm actually building it. Let's show you how this works. Rather than build them, I'm just going to call PCB support one of them, so you can see what's going on. So back up here in our build, I'm just going to call the method to build one object and run it. And what you should see is one of these corners is going to fill up with a triangle. Now I chose a triangular support. I could have used round one. These are standoffs basically. So I could have used squares, triangles, cylinders, anything. Cone. A cone, by the way, is built out of a cylinder. So you just change the bottom dimension of your cylinder and you get a cone. You can get whatever shape you think. The easiest one is the triangle, I think, because it just cuts away. And I've decided to make it longer in the Y dimension than in the X. So I've said it'll be twice as long in the Y dimension. So I could actually do this. Because I've decided I want it to be twice as long in my Y dimension, I could say multiply that by 2 and I'd still get the same result. See that? And if I change this to 5, I'll get a 5 by 10. And you saw it grow, right? Now I like this thing here because in the Y dimension we've got lots of length and it needs to be a little bit stronger in the Y dimension, but in the X it's pretty short, so this shorter dimension, half is fine, right? I could turn it into thirds by saying times 3 and then changing this down. You don't need a lot in the X dimension. Now down here I've got my cutout offset as being 3. What this means is that I always want it to be, I've got to build my cutout so that it clears these supports. So I've said put it within 3 millimeters of the support. Now I've started talking about the cutout, but that has a relationship to this X value, so that my cutout will actually start that plus that away from the edge of the box. So you've got to keep that in mind. Now the reason I said that is because in this project I have not built in any sanity checking, which means I could conceivably cut this box right past the end of that. It could go out here somewhere, my cut, so I could have my whole cut blasting through everything. I could have supports Well, these are actually tied in, so it's built within the software, but my support could be built out there somewhere. But the way I've developed it, I've already given my X and Y limits up here, and I use them in the module. So down here, where I talk about, I've got my X value. Now, what this translate does is it moves the point of build. So what I've said is that I want you to go out X, where's X? X is this way. Now, if I went out the full value of X, I'd be out here somewhere. Let's just do it to show you what happens. So if I hadn't divided that by 2, this triangle won't end up where I want it. See, it's out here. So all I've done is I've put the triangle, but now I've put it in the wrong position. So by doing a simple bit of math and saying, well, I know that my chassis is centered about the origin. You see that? Everything is about the origin. So by doing a little bit of thinking and logic, put it where I need it. There it is. Now remember our little highlighter? So if I use this little pound sign, see it gets highlighted, and I can see exactly where it's running, and I can see that it's beautifully touching out all of those surfaces. There's no gap underneath it, which is perfect. I want that to be a standoff from the base. Now it took a little bit of thinking to get this right, but I got it. I had to play with it a bit. But you can see now too, it's also the correct height. And the reason it's the correct height is I had to add back the thick in order to make it touch the base. Okay, if I just use Z, I was only giving it the inner dimension, and I was getting some really funny things at the mating surfaces here. So make sure, you know, that you want to get your support up to there, because what I'm actually doing is the PCB rebate cuts this back. So when I build my PCB support, and I'm going to go into that now, I didn't want to build this 4 times. So there's a really handy thing called mirror. And that's, what is it? It's a transformation, I think. Here it is here, mirror. And what this allows you to do is copy what you've already built. Okay, so there's a very complex thing. You can imagine how much time it took to render that. And rather than go through and type it out twice, everything in reverse, what he's done is he's just used mirror. So he's got 2 hands. He's got a left and a right hand. It's the same with this. You can mirror things at an angle. Yeah, I'm not going into it. You can change colours. You can do all sorts of things. But this little cheat sheet will get you out of trouble. So you get the syntax off that. You come back to your code and you just use it. So let's go down here, and here we go. Build them. I'm building one and I'm using it to mirror to the other side. And that I've used union, right? And then I've just taken that whole thing. Let me just comment this out. By commented out, I mean deleted. So let's just do that for one. There it is. It's mirrored. And then I've taken all of that and mirrored it to this side. Control Z. So you can see those two. Now you can see those two. And by a couple of commands, I didn't have to type all this out and run all that script 4 times. It's actually done that for me based on what I fed it. So this is mirrored around the X-axis. This is mirrored around the Y-axis. So by doing 2 mirrors, I've actually built everything I want in the corners of my box. And they're proportional based on these values here that I gave my first build. Okay? I only built it once. I didn't build it 4 times. The software did that for me using mirror. So now we've got our supports, we've got our box, which is actually our full chassis. Now why didn't I put that under chassis? Well, I could have. I could have taken this out of here and put it here. So now our chassis is built up of a box and some standoffs. And you can see we've got the exact same result. The point is, I like to keep the chassis as being the chassis and the supports as being another object. Some people might argue it's part of the chassis. Well, I'd argue against that. I think, like, if you had to build this up, you'd have to weld those on, right, or glue them on. So I'm saying they're separate. They're four little bits that get glued in there or mated in there or whatever you want. Righto, so now we've got to do our cutouts. And our cutout has, we've got 3 of them. Let's go back over to the camera for a sec. Yep, I've just been editing part 2 of the series. And I've got 1.5 hours of footage, so it's too long, and I can't cut it because it'll lose its impact. So I'm going to split it into 2 halves, and what we're going to do is we're going to have part 2 as 2 parts. So part 2 has become 2 parts, part 2A and part 2B. Look, it's just that to post up 1.5 hours of footage, to upload it, with my connection here, it takes an inordinate, it takes more than half a day to upload that. As it is, it takes nearly 1.5 hours to upload my videos from this connection. That's because of the service we have here. That's what we've got. That's what we do. So that said, I'm going to chop this video at this point and start part 2B in the hopes that you will continue to persevere. Look, we've got to continue through this process of design. It's important that you understand that the process I'm teaching you is a professional process, right? It's not just some amateur. This is what I did for 27 years. And I'm passing this knowledge on so that, you know, maybe you can benefit from being neat and organized about the way you lay your code up, and learn something about object-oriented design. It's not just about how you program, it's about how you design. It's about how you identify your project and break it into things that mean things to anybody that looks at your work. That's the key to being a good part of a team. You know, I could hand this off to anybody with half an ounce of competence, and they could just pick it up and do it. And that's the test of good work. That's it. That's the standard bear. Can I give this to someone and with very minimal instruction, they can go away, given that they know their craft, and come back with what I asked for. That's it. That's good design. This tool, this sorry, what are we using? We're using OpenSCAD. We're not using AutoCAD. We're not using SolidWorks. OpenSCAD is a poor man's solution, but it's not by any means a less powerful one. This is the basics of CAD design, given to you for free by OpenSCAD.org. Now, I want to encourage you to donate to those guys because they've, like me, given back to the community. They've put in their experience, developed this thing, and given it to you for free. And, you know, if you don't donate, well, they can't feed themselves either. And it's no different to me saying that I want you to support my company, nightglowmanufacturing.com. It's the same deal. If no one does it, then, you know, we're finding it difficult to make ends meet. And we got to come up with actual jobs that feed our families. It's kind of cap in hand. And look, at the end of the day, anyone that asks you to contribute to their channel or whatever, There are people out there that have got thousands and hundreds of thousands of subscribers, and they sell their merchandise so that they can keep that channel going. And to a degree, that's a form of entertainment. I'm not doing this for entertainment. I'm not doing this to make millions or become famous or any of that. I'm doing this to give back to YouTube. That's it. So when I say please support nightglowmanufacturing.com, that's my company, that's my business, and it's saving the planet. It's out there trying to teach people about eco-manufacturing. And without it, without that income source from my family and myself, I can't do this sort of stuff, right? It just doesn't happen. I've got to have a job. I've got to have something that feeds us. And at the moment, I don't have any of those things. And I started up Nightglow Manufacturing to put that in place. I've been crook, and there's a welcome video in Wiley11 that if you're not familiar with my story, go watch that. And you'll see I've overcome a lot to get to where I am. Okay, enough of that. Like and subscribe to the video. Subscribe to the channel. Like the video. If you like what I'm doing, if you don't like it, don't bother. But let's face it. There's very few people with 27 years of experience that get on YouTube and give you the benefit of that. You can probably count it on your hands. You could count to it very easily. There might maybe 100, 150 people in the world with 27 years of experience in an industry who impart that to you for free, which is essentially what this is. Right, like the video, subscribe to the channel, comment please, by all means, give me your comments, give me your feedback. If there's something you want me to explain in further detail, make it relevant to what I'm doing here, which is the 3D printing. This is the final in this whole series. Somewhere I've got assembling the 3D printer as a kit, and I've just found out that it didn't actually upload because of whatever reason. I set it uploading. The bloopers reels uploaded, but the actual build didn't, and the build is way longer than the bloopers. But there's enough in the bloopers that you can build your kit and avoid all the pitfalls. The bloopers were all the pitfalls I came across while building the kit. It's a cut down version of the build. Alright, I'm going to get on with this. Like and subscribe. Support my nightglowmanufacturing.com. And I'll see you guys for part 2B.